Hello friends. This video is brought to you by mywayteaching.com.
Let us recall that triangles are also polygons, so we can state the same conditions for the similarity of two triangles. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio or proportion. Now consider an equilateral triangle where AB is equal to BC is equal to CA, and all the angles by definition of equilateral triangle are of 60 degrees. Now if we take another equilateral triangle, say PQR, again all the angles will be of 60 degrees. We can say that triangle ABC and triangle PQR are equiangular triangles, and a famous Greek mathematician Thales gave an important truth related to two equiangular triangles. The result says that the ratio of any two corresponding sides in two equiangular triangles is always the same. This result brings us to the conclusion that triangle ABC and PQR satisfy both the conditions for them to be similar, that is, their corresponding angles are equal and their corresponding sides are in the same ratio, so the two triangles will be similar. Note that if corresponding angles of two triangles are equal, then they are known as equiangular triangles, and then we can apply Thales' result to all equiangular triangles. Let us now state and prove basic proportionality theorem or the Thales theorem. If a line is drawn parallel to one side of the triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Let us start with the proof. We are given a triangle ABC in which a line parallel to side BC intersects the other two sides AB and AC at the points D and E respectively. We need to prove that AD by DB is equal to AE by EC. That is, the sides are divided in the same ratio. For the proof, let us join BE and CD and draw perpendiculars DM on perpendicular to AC and EN perpendicular to AB. Now considering AB as the baseline, let us find the area of triangle ADE. It will be half into base AD into height, which is EN. Also consider triangle BDE. Area of triangle BDE will be given by half into BD into EN. Similarly, consider AC as the baseline, then area of triangle ADE will be equal to half into base will be AE into height will be DM and area of triangle DEC will be half into EC into DM. We now take the ratio of area of triangle ADE by area of BDE, in which half gets cancelled, EN gets cancelled, and we get AD by BD. Similarly, we can take the ratio of ADE by DEC, which comes out to be AE by EC. Let us mark these two equations as 1 and 2. Now, since triangles BDE and triangle DEC are between the same parallels and on the same base, so area of triangle BDE is equal to area of triangle DEC. From first, second and third, we can see if we substitute area of DEC equal to area of BDE, we get left hand sides equal, so we get right hand side also equal. We have AD by DB is equal to AE by EC. So hence we have proved basic proportionality theorem. That is, a line drawn parallel to one side of a triangle intersecting the other two sides in distinct points, then the two sides are divided in the same ratio. Now look at the converse of basic proportionality theorem. The theorem says if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Here we are given a triangle ABC and a line DE such that AD by DB is equal to AE by EC, and we have to prove that DA is parallel to BC. For the proof, let us assume that DE is not parallel to BC. If that is the case, we can draw another line DE dash such that it is parallel to BC. Then by basic proportionality theorem, the ratio AD by DB should be equal to AE dash by E dash C, and also it is given that AD by DB is equal to AE by EC. Both these imply that AE dash by E dash C should be equal to AE by EC. Now let us add 1 to both sides of this equation. Then left hand side becomes and the right hand side becomes EC as LCM AE plus EC. Look at the numerator. AE plus EC means AC. While AE dash plus E dash C should also be equal to AC. This means E dash must coincide with E. We can see that E and E dash must coincide. Hence we have proved that DE must be parallel to BC. In other words, the converse of basic proportionality theorem is true that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Like here we have proved that DE has to be parallel to BC.